Hello, hello, hello. Cheers, Kevin here, and welcome back to TIS-100, where it has occurred to me, I've been doing some thinking, we did this really bad version of this program. This required us to subtract A from B and subtract B from A and push those things down. It occurred to me that A minus B is exactly the negative version of B minus A, and so this whole program that we wrote in this very, very stupid way, we can do faster. So, I'm going to return to our segment list. I want to make a better version of this. I want to see what we can do. So, and then we'll move on to additional steps. So I don't know if there's any value in us getting better solutions to this, but heck, we're going to do it anyway. So first we've got to move from up to the accumulator. Then we're going to move, then we're going to subtract from the right. Then we're going to move accumulator down, and then we're going to negate, and then we're going to move the accumulator down. Okay. So what this is going to do is it's going to first get the thing that we get in, put it in our accumulator. Then we're going to subtract B from it. So we'll have A minus B in our accumulator. We're going to move that down. We're going to be like, here's the one answer. And then we'll have negate, which is going to invert our accumulator. And then it will move that one down as well. Now we'll have to worry about getting all this. But here, all we're going to do is we're going to say move up to left. And here, I'm just going to cheat for right now. Move up to down. We're not going to worry about this just yet. Move up to down. And let's just step through this and make sure that this works. So, we get the thing from the up value. It's 44. It goes in there. We subtract the value on the right, which is 93. We get negative 49. We push down negative 49. Now we negate, which gives us 49 positive, which is also correct. And then we'll push that down. And then that goes down. So now we're getting incorrect values here. Yep, see, there we go. Now we got a bump because we need to be filtering the things to the right areas. But that's correct. So, the first one is going to be the correct value. The second one is not going to be the correct value. So, actually, we'll just go ahead and split it down here, right? So, first one should go into the P bucket. The second one should go into the N bucket, because that'll be the inverted one. So, we'll say move up to right. And here, we'll say move left down. There we go. Now, we're only using 5 nodes. We're doing much less work, I suspect. Let's just step through this and make sure that this works. So, we get 49 is going to go down here into the... let's see, yeah, negative 49 already went out. 49 is going to make its way over to here and end up in the N bucket. And, yeah, we're going to process through. It looks like this is going to work. All right, let's go ahead and stop, and we will run it. And good, we're still getting all the same values. We're using much fewer lines of code. I don't know. There may be a way for us to do this a little bit faster. I'm not sure. But I can't think of anything at the moment. Okay, 277 cycles. That's better than what we were doing before, wasn't it? Wasn't it, roughly, I think? Yeah, because we were doing this whole, like, all right, first we'll wait, and then you can take a turn. There we go, okay. 277, still not the best that other people have come up with, but not the worst either. And we used 5 nodes instead of 6 nodes, and that's good. And we've used, I guess, the minimum number of instructions, so that's something. Let's return to our segment list. Okay, so yeah, our first one is 393 cycles. That is a lot of cycles. All right, we're going to go ahead and move on to the signal comparator and see what we can do here. Signal comparator. So, read a value in from A. What is our problem here? Read a value in from A. Write 1 to out G if in... Wait. If in is... Oh, right. Oh, sorry. No, read a value... I'm sorry. Read a value from in. Write 1 to out G if in is greater than 0. Write 1 to out E if in is equals 0. Write 1 to out L if in is less than 0. When a 1 is not written to an output, write a 0 instead. What? Oh, okay. Okay. Well, let's look at this communication failure. Let's see some flavor text. Compute node diagnostic microcore dump. Found a block of static memory, but it's a proprietary format I never saw before. Can't make heads or tails of it. Oh, brother, there's just too many different kinds of machines coming out now, and I like tinkering with them as much as the next guy. But when every Tom, Dick, and Mary implements their own memory address scheme, it's all... I say the bottom's going to drop out of the microcomputer market soon. Mark my words. Okay, so we have to figure out what to output here. We need to put out a 0 or a 1, and it's actually showing us the input. So if the value is greater than 1, basically we're saying we're only going to send a 1 to one of these for each input. The other one should get 0. So first I guess we got to just move up to down. Oops, move up to down. And we'll go here, move up to down. And here we'll move up to right. And here, I guess what we've got to do is we need to do some comparator stuff. Now, if in other languages we would have things like if. and you'd have conditions and stuff like that. We don't have that here because we're working in assembly language stuff. So now we're going to have to use some fun craziness. I'm going to say label. No, we're going to, yeah, this is how we do it, labels. So that's a label. And let's see. Now, yeah, we'll put a label down here just for now. Match. Let's assume, so this is a label, and this is something that we can potentially jump to. Well, first what I'm going to do is I'm going to move what we have on the left into the accumulator. And now we have to talk about jump commands. So JMP, I think, is, yeah, so JMP is a jump command. And basically it would say jump to match. This would be like, okay. And then if I had some whatever here, move down to up, it would skip over this line and move directly to this match line, which I'm trying to highlight, but there we go. It would skip over this line entirely because it's saying, we're telling it, hey, jump. Skip over some code. Now, there are some variations on this. Jump equal to 0, which will jump if the accumulator value is 0, or jump if greater than 0, and jump if less than 0. And those are going to be the ones that we're going to be using. So, actually, let's go ahead and put a thing here. Start is going to be move left accumulate. Yeah. Okay, so that's what we're going to say to jump back to immediately. We'll start with the base case. So let's assume. All right. So our start is going to be that, and I'm going to just end up copying and pasting this, I think, into here, and we'll just change the jump thing. So let's assume by default that there's not a match, because out of these, 2 of them are going to not have a match. So we'll say if. No, we won't say if anything. We'll eventually have to have some sort of jump command. We'll worry about that in a minute. But if we didn't get a match, then we just have to move, let's see, we have to move, should we move, let's see, we need to move a 0 to down, and we need to move accumulator to the right. But I'm wondering if it's faster to do it the other way. It probably doesn't matter, but who knows, I could be wrong. All right, and there we go, and that would be that, and then once we're done with that, we don't want to go to this whole, hey, we found a match thing, so it would say jump to start. That is our positive case. Now we have to do the actual test thing. So we'll say if... Actually, can I leave empty lines in here? Is that going to count them as expressions? It probably won't. It's probably fine for us to use white space to delineate stuff. Okay, so what we want to do, so out G, if it is greater than 0. So jump greater than 0 to match. There we go. Wonderful. Oops, no. Match, just without the semicolon. And what would the match version do? Well, it would move a 1 down, and it would move the accumulator to the right also. And then it would also jump to the start. So, there's some shared code in here, right? This whole jump to the start. The only thing, and these don't necessarily have to be in the same order, so we can put that up here. Now we've got these 2 lines of shared code. That's kind of dumb. Let's go ahead and see if we can clean that up a little bit. So we'll say... let's see, jump if greater than 0 to match, otherwise, let's see, we'll call a label then. So match will do this. Well, the label then will not worry about this. We'll just say, hey, move the accumulator to the right and jump to the start. That's all that's going to do. Match is going to go move a 1 down, and otherwise, let's say jump if greater than 0. Otherwise, move a 0 down. So now we can get rid of, yeah, we can get rid of this line, we can get rid of this line, we can get rid of this line, I hope. And actually, we don't need this jump to start now. The only thing that we need here is a jump to then, so that we don't move a 0 and a 1 down. So, okay, let's think about this. So, we start off by saying, all right, get the value that comes in from the left of us. And if it is equal, if it is greater than 0, then jump to the match label. So skip over these 2 lines, skip over those, and go to the match, which means it'll move a 1 down, and then it will use this next, it will continue going through, it'll move to the next line, it'll say, all right, and then we'll move the accumulator to the right, and then it will go back to the beginning and start to move a new value in. If it is not a match, then we will move a 0 down, and we will jump to then, which skips over this match line, and moves to our then, which moves the thing to the right. So, okay, this should hopefully work. Let's see if I can get my cursor to play nice. We're going to go ahead and copy these over here, and I'm going to say the only difference here is that we've got jump if it is equal to 0, so JEZ is the short code there, and this is jump if less than 0. So, okay, I think we're in a good place. Let's see if this works. So, we have a 2 that's coming down the pipeline. The 2 comes in. We move it into our accumulator. It is greater than 0, so we should jump to the match, which you see that it does. We're going to move a 1 down. There we go. And then we're going to move our accumulator over to the right, which we do. And then we're back now over. We're ready to process the next input, which is going to be a 1. And over here, we're checking to see if this is equal to 0. It is not, so we didn't jump. Now we're going to move a 0 down, and we did. And now we're going to jump to the then, which is just the, we should probably call that next or something, I don't know. But we did move that out. And we can see up here, we're already getting, these are coming in, disproportionately, but we got the 1 and we got the 0. Now it's just a question of whether this last one is going to take its value. So it gets the 2, and it sees, is it less than 0? No, it is not, so it moves it down to then, and there we go. And look at that, if we step through, nope. What? What's going on? Oh no. Oh, derp. We don't actually need that on the last one. He doesn't need his hand off his value. Stupid me. And actually I'm wondering, one thing we could do, well, okay, actually we don't need the label start because it's not referring to it. Let's run this real quick and just see if that works. Oops, I gotta stop it, I think. No. What? Nope, I can't stop it. Okay. Oh, there we go. Jump to that. Oh, right. Jump. Oh, right. Okay, so we got to jump to the start then. Yeah, okay, so we do need to start there. I'm wrong. All right. Run. And we get all the values. I am wondering if it makes a bit more sense for us to throw the values over to the right off the bat. Like move left to the accumulator and then put the thing right at the top. I don't think it'll matter too much. 280 cycles, 283 cycles into test 2. So not the same in 282. So slightly different number of cycles, which makes sense because it would vary how many lines we execute based on how that ran. But okay, not the worst. We're a little over what apparently some people managed to pull off, but we're on the low end of instruction counts. And there we go. We have now fixed our signal comparator. Let's return to our segment list and find what we can find. And I am just noticing right now that my audio's been not recording in the good place. So I apologize for that. I also now don't have a good sense of how long I have been recording, which is embarrassing. So yeah, well, I apologize for the audio at the beginning of this video is a little iffy, but the rest of it should be corrected. Let's go ahead and see if we can get this multiplexer going just fine. All right, so well, let's look at our communications failure. Computer node diagnostic microcore dump 13180. I might have an idea of where this TIS-100 machine came from. Described the architecture to Fred at Motorola, and he says it sounds like it was designed for signal processing. That got my brain going. Government project, maybe. Something the CIA cooked up to comb through Soviet radio signals. Hush, hush, top secret. FP. Maybe. Could I be in possession of a classified device? Something for spooks? I might have to sit on this one for a little while. Alrighty. So this is a multiplexer. What are we doing? We're reading values from NA and NB. We're reading a value from NS. Okay, so we've got these different things. Write in A when NS is less than 1. Write in B when NS equals 1. Write in A plus in B when NS equals 0. Okay, so we need to output a different thing based on, so S is our signal that's determining what we're going to put in. Okay. Well, let's think about this. So we've got A. Okay. Well, we know from here, move any to down. That's pretty easy to figure out, I'm assuming. Let's see. Actually, no, this shouldn't be too bad. So if yeah, so what we're going to do is basically we'll have something that accumulates, I think. Yeah, we'll have something that accumulates from the left and the right. Let's see here. Okay, so we'll move, let's see. Here we'll just move up to down. No. We'll move up to the left. No. Well, let's do it in a dumb way first, and then we'll make it work and then make it good, right? So let's move up to down. And then here I'm going to go, actually, no, we'll move up to the accumulator. We'll move up we'll move the accumulator to the left, and we'll move the accumulator to the right. So now these fine folks are going to say, move left into the accumulator. No, they're not. What are we going to do? How are we going to do this? Okay. We need to find a way to save the value and then push it in, right, and put it back if, right. So we are going to need to do some saving and some swapping stuff. All right. Fine. We'll do this way. So we'll say move up to accumulator, and then we'll say save, and then we will say move right to the accumulator, and then we will say now we've got to do our logic. So we'll say if in S is later, let's see. So if the signal, so we need to determine whether we care about this A value. And either we're going to put down something, we're going to push down either a 0 or a 1, or we're going to put down either a 0 or A, and we're just going to add those values together. So here we'll say, yeah, sure, move up to the right, and here we'll have move up to the left, to the left, and then all we'll do here is we'll say, let's move 0 to the accumulator, and then add left and add right, and then move the accumulator down, and here we'll say move up to down. So this is just going to add whatever values come out. So it's our job to figure out in these two blocks whether or not we should push down a 0 or we should push down the value. So this spreads it out. Then we decide, hey, are we going to push that signal along, or are we going to kill it? So A should be the case. We do need to put out A if it is 0 or if it is less than, or if it is -1. I'm going to assume that any negative value is probably fine. Well, no, but also, yes, okay. So we only get 0s, 1s, and -1s in this for S values, so we should be okay with that. Let's see here. So what we need to do is we basically need to say, hey, if we're going to go greater, if the value is greater than 0, then don't do anything. Then output a 1. So jump if greater than 0. So we can put that value into our accumulator. We'll say jump greater than 0 to, we'll call it label 0. Now we need to create a label called 0. We'll put a start up here. Okay, so we'll worry about the 0. This is the, well, no, let's do the 0 right now, because that one's soup's easy. So we'll go ahead and just say move 0 down. Otherwise, if we have the regular value, then we need to swap the backup, because we got the value from our input, and then we saved it. Oh wait, we don't need to save it yet. No, we don't need to save it because we don't even have to worry about it. We can do that after we get stuff. So start, move the value from the right. Oh, dang it. Okay. Begin. No, it's too many characters. I can't. All right. Fine. We'll put A. There's our label. Move the right to the accumulator, and then we'll just branch off of that, and then we don't care. We don't have to save it. We can then go ahead and grab the value. So here would move 0 down, but we also would need to move, well, no, we can do it in either case. Okay. We'll move right into the accumulator. Then we will decide what to do based on that value. So if it is greater than 0, we don't need to swap anymore. If it's greater than 0, then we're going to ignore it. We're going to output it. We're going to move a 0 down. We also need to clear out the value from the input. So we'll go ahead and just say move up to nil. I think that's nil. No. No. Invalid register null. I may have to pull up the instruction manual. Let's view the manual. Give me just a moment. No. Come on. No. Oh, does this not have text search? Oh no, it's entirely an image. I'm gonna have to scroll through this. Oh no, it's nil. It is nil. Okay, I'm sorry. Nil with 1 L. Right. Move up to nil. So we're saying take the value and throw it away, and then move a 0 down. Otherwise, we'll go ahead and say move up to down. And that's all. That's all we need to do here, right? So we'll say, hey, if it's a value we should ignore, then we have to throw away the value. Otherwise, we'll pass the value along to our friends. And we do want to make sure that we don't go to this 0 label. So we'll want to go ahead and say jump to A. And let's see, is there anything else we should? No, this looks good to me. Undefined label. What? Oh, whoops. Without the colon there. All right. And we'll push this down here. Now, the only thing is we need to change the logic to less than 0, because if we're less than 0, for whatever reason, we should not have the b value be a component. So, okay, I think this is going to work. Let's step through. First, so we move up to the accumulator, and then we move to the left. And then we're sending, hey, it's a -1, and then A gets to decide what to do. Then we tell B it's a -1, so B can decide what to do. And A has decided, cool, I'm included. I get to participate. B is going to decide, come on, B, what are you doing? Oh, whoops, B is wrong. B is trying to grab stuff from the right, and there's nothing on the right. Sorry, B. All right, let's do that again. B is waiting. B, there you go. Less than 0. So it's less than 0, so the B component doesn't matter here. So B is going to just output a 0. And now it gets a 0. And here our adder is just waiting for those two values. It's going to add that 0, and it says, all right, I've summed them. I'm going to go ahead and push that down. We get our first value correct. And if we keep going through this, now these are all going in kind of crazy different orders and stuff, but it looks like we're getting the right values. So let's go ahead and run this. Let's do it. Come on. Oh, look at that. 204 cycles. We could probably do this I don't know. Could we do this in a cleaner way? Like, we have to, there's not a good way to just be like, hey, send it to anybody. Wow, look at that. Actually, it looks like we did better than most people. We had 204 cycles, and most people ended up at far more than that. We ended up using one more node, I guess, than most people did. Is there a better way for us to manage that? And we have more instruction counts. Let's look. I want to look real quick. Is there something that immediately strikes us? Like, is there one of these? No. Nothing immediately comes at me as stuff that we. I mean, I suppose we could use this as the. We could use this as the A value, couldn't we? I think that would end up being more cycles, but we could. No, we still have to use. No, because these both have to get inputs. How the heck do you end up with less than? Well, I guess they may have this one both sending the signal over to A and also maybe ingesting the value from B, and then worrying about the logic of B. But it feels like that would probably slow things way down. But okay, I'm pretty happy with this one. Let's go ahead and go back to our segment list, and look at that. We've unlocked a whole nother sequence of stuff. So that'll be particularly fun for us to do. But of course, that will have to take place in the next episode, because I have no idea how long we've been going, and I don't want to bore you all to tears. So I will see you then. Cheers.